pH stands for the potential of hydrogen. The pH scale was invented in 1909 by a Danish chemist by the name of Søren Sørensen, and it is used to determine the acidity or alkalinity of a substance. The scale ranges from the numbers 1 to 14, 1 to 6 being an acid, 7 being neutral, and 8 to 14 being a base. According to dictionary.com, an acid is a chemical substance that neutralizes alkalis, dissolves some metals, and turns litmus paper red, and it's typically a sour tasting liquid. A base is a substance capable of reacting with an acid to form a salt in a water, or accepting or neutralizing hydrogen ions. So the mixing of an acid and a base will neutralize a solution, and this can be shown by the formula H, which is an acid, plus OH, which is a base, will come out to make H2O, which is neutral. So litmus paper is used to detect if a substance is an acid or a base. So litmus paper will turn blue if the substance is basic, and it will turn red if the substance is acidic. And this is one of the most commonly used forms to detecting whether a substance is an acid or a base. So I'm just going to do a quick experiment showing you guys how to test the acidity or alkalinity of different substances, and you can do this experiment in your house, it doesn't matter. So I just picked 3 kind of simple, basic products. So I picked vinegar, water, and floor cleaner. So we're gonna see what each of them turn out to be. And I'm just using the universal indicator paper because when I grabbed the litmus paper at school, I accidentally grabbed an empty container. But this does the same thing. You'll put it in and it'll give you a more accurate reading. Oh my goodness. As you can see, like, it tells you the exact pH depending on which color it is. So first one, we're going to dip it in the vinegar. We're going to see what color it turns. Next one, we're going to dip it in the water, see what color it turns. And the last substance is our floor cleaner. We're going to see what that turned into. Whoopsie, it fell. Okay. So we're going to wait to see what color they turn out, and we'll tell you the results. So I'm just going to show you guys the results of the experiment that was conducted. So the first was the vinegar, and that turned a red color. And if you see on our universal indicator, a red is an indicator of a pH from around 1 to 2, so it means that vinegar is a strong acid. Next was our water, and water turned out to be a yellow color, and that is an indicator of a 7 on the pH, so that's neutral. And then our floor cleaner turned out to be like a yellow green, so that's an indicator. It's around a 12 on the pH, so it's more of like a deep yellow, so that's a base. So you can see I tested 3 different things, and you can see how litmus paper and also universal indicator papers are used to determine the pH of a substance. Litmus paper more tells you like if it's an acid or a base or neutral, while this will tell you the exact pH it is around. pH is important because it can have a very great effect on our environment, humans, animals, etc. If a pH is too high or too low, it's not good for the surrounding and habitat environment, whatever it is, because it can cause great damage to us, the animals, the ecosystem. It's not good if a pH is too high or too low, and here are some examples as to why. natural factors that influence pH. So CO2 makes water very acidic. So photosynthesis, decomposition, respiration, these are all influenced by CO2. And this causes the pH to go high or low depending on the instance. So water can form carbonic acid if it comes into contact with CO2, and carbonic acid will either lose 1 or 2 hydrogen atoms. So any lost hydrogen atoms will lower the pH, while if CO3 picks up the hydrogen atom, then the pH will go up. So another instance is raindrops. If raindrops come into contact with CO2, which creates H2CO3 in rain drops, it could lower the pH of rain. So that's another instance. Other natural factors that influence pH are sometimes carbonates combine with the hydrogen ions and they neutralize the pH level. And other times when rain lands on a surface that isn't exactly the smoothest, it can decrease the pH level of the water that fell. Some man-made pH influences are also an issue. So one of the biggest ones is acid rain. So acid rain is anything with a pH below 5. So the rain will react with nitrogen oxides and sulfur dioxides, and it will make acid rain, which is very harmful to our environment. It comes from the burning of fossil fuels and the abundance of too much CO2 in the air. And another thing is when chemicals are dumped. So when chemicals are dumped, they will mix with the water and it will alter the pH levels. So the effects that pH can have on our environment are a wide range. So for example, with our aquatic life, so the pH for our aquatic life in the oceans, lakes, rivers, the water must be around a 6.5 to a 9.0. So if the pH is too high or too low, it's very toxic to the fish in the aquatic species and will stress them out and they will eventually die. And with that happening, the mortality rates go up, the species are not reproducing, so there's just going to be an issue with the animals. They're going to become extinct if the pH in the habitat becomes too high or too low, because it will be toxic. So after the pH reaches 10, ammonia is released into the water and it just makes it too toxic for the species to live in. So another thing with our drinking water should have a pH from 4 to 11, because if not, it will cause gastrointestinal difficulties in our system. So a pH that is too high will cause damage to the skin and eyes, and if it's too low, it can cause severe damage to our internal organs, and that's not good either. Lastly, we're going to talk about the swimming pools. So in a swimming pool, it is also often filled up with water and people swim in it, but we need to disinfect it, so we have chlorine, etc. So a pH above 7, the water is basic, and if it's below, it's acidic. So the optimum pH for a pool is 7.4, because that is the same as the pH in our eyes, so it's not going to harm us in any way. And also at the same time, while not being toxic to us, it gives the pool a good disinfection, so it's clean and not full of germs and bacteria that can often maybe harm us or even kill us if they're dangerous. So a low pH, it's very aggressive, and it damages the actual pool itself, and it irritates our eyes, and it just damages the pool, like the liner, the mechanical component. And a high pH, it doesn't clean as well, and it'll irritate our skin. And since it doesn't clean so well, that's when you will see the muggy water. It's kind of cloudy looking, so it's not clear, you can't see through it, so it's not the best either. You can find more information on this topic as it's featured in chapter 10 of the McGraw-Hill-Ryerson Chemistry 11 textbook. But to end this off, overall, yes, pH does play a very important role in the analysis of water. So you can see that if the pH is too high or too low, it's altered even by one number on the pH scale, that it can have a serious effect on our environment, us as humans, animals, etc. So I hope you guys learned something out of this, and